Hi, class. So today is the second strategy that you can use to help you add integers. And this is called number lines. So you use the number lines and physically model the addition process to end up at your final answer of your expression or your simplified answer. So the way we're going to start this is we're going to start just like we did the last video, and we're going to start with our steps. I always like to highlight steps just so I know that these are the ones that I can always come back to, right? This is probably the most important part of your notes, having your steps down. So step one is first you have to create a number line. Now, when you create a number line, you have to use number sense when creating said number line. So what I mean by that is oftentimes we will have 0 in our number line, right? And then we often have positive numbers and negative numbers on the left side. However, 0 doesn't have to always go right in the middle, right? You look at your numbers and you determine, do I need a lot of positives, a lot of negatives, only positives, only negatives? And then you form your number line around that. So always make sure when you're creating your number line, you use number sense. After you create your number line, you color code your numbers in your expression. Now, this is an extra step, but I find it very helpful. So if you have a positive number, you are going to color code it green, right? Or whatever color you want. I usually use green. And if you have a negative number, you're going to color code it red or whatever color you choose. So I'll put that right here. Positive is going to be green. Negative is going to be red. All right. So now we start working. You take your first integer in your expression and draw a line above your number line that represents the integer value. So a lot of writing right there, but you take your first integer and you go above your number line and you draw a line above it, that represents the value of your integer. Now, it's really important whenever you start a number line. So I'm going to put a little star here and highlight it because this will always be step 3. But whenever you start a number line, you start at 0. So again, 0 doesn't have to be in the middle, like we said in step 1, but you should have 0 represented somewhere on your number line. And that is where you start. And from that line, you draw another line above that represents the value of your first integer. A little confusing. When we model it, it will make a lot more sense. So after you do your first integer, what you do is beginning where you ended in step 3, you draw another line above that represents your second integer value. So beginning where you ended in step 3, you draw another line above. So above the number line originally, above the line you just drew in step 3. So there'll be 3 lines in the end, but it will represent your second integer value. Now step 5, where you end in step 4 is the answer. And I always like to highlight the answer, but again, you can see that modeling. Okay, so now let's put these steps in action. If you need, pause the video, take a couple minutes to finish writing down these steps. I'm gonna go on and we're gonna model this now. So step 1, create a number line. It's really important that you're neat in your number lines, as I said, just with integer counters before. I pulled in a picture of a number line. If you don't have a picture that you can pull up or a teacher didn't provide a number line, a ruler is always a really good start, okay? So I created the number line. Notice I haven't labeled the number line yet because I need to figure out what my expression is. Well, my first expression is going to be 3 plus -5. So I'm looking at that. I have 3 positives and 5 negatives. That means I'm going to have to favor more negatives in my answer on my number line, right? Oftentimes, right? So that's what I know. So 0 doesn't have to be in the middle, but I need less positives than negatives. So I'm going to put 0 like right here. 1, 2, 3. -1, -2, -3, -4, -5, -6, -7. So there's my number line. Again, this kind of makes numerical sense. I have more negatives in my expression, so therefore I have more negatives in my number line. I have less positives, so I put less positives on my number line. 0 has to be there, and it is. Okay, now we're going to color code my numbers in my expression. So 3 is positive, just like I did with integer counters. I'm going to box it in green. -5 is obviously negative, so I'm going to box it in red. Okay, so what's the first integer in my expression? The first integer in my expression is +3. So what I'm going to do is I'm going to put a little dot at 0 because remember, we always start our number line at 0. And I'm going to draw a line above that represents the integer value of +3. Well, if it's positive, it's going to go forward to the positive side, and it's going to end right at 3. I always like to put an arrow to show that it went positive. So this represents +3. I like to put it right above, be really neat. And that's it. So now what I do is I go to step 4, which says beginning where you ended. Well, I ended here, +3. So I'm going to create a line above where I ended, right? This is where I ended in the last step. If I bring that up, that's where I start my next line. And now I'm going to do a value that represents the second integer expression. I'm going to draw a line. Well, that's -5. That means I have to go back 5. So I no longer go forward, I'm going back because negative represents going back. Not only do I have to go back 3, I have to go back another 2 to get a total of -5. So where I end up after my second expression, which is right here, ends up being the value of my expression. So what is 3 plus -5? It's -2. For the 3 I went forward, I had to go back 3 and another 2 to represent -5. Well, where did I end then? -2. All right. Let's practice 3 more examples now, similar to what we did in the integer counters video. Additionally, if you haven't noticed, I am actually doing the same examples as I did in the integer counters video, and what you'll see is you're getting the same answers. So it's really cool to understand both strategies so that you can always check yourself, right? If you do it with integer counters, we'll do it with a number line and see if you get the same thing. If you did, chances are you're right. More tools we learn, more strategies we learn, the better off we are. So what's our second expression? Our second expression is 5 plus 1. What I'm going to do is I'm going to call in a number line right now. Because I find it easier. Sorry, I'm taking a little bit to move it. There we go. Going to make it a little bit bigger. So I brought up my number line, step 1, or you can create your number line, right? The next thing I'm going to do, I'm actually going to lower it down because I usually draw my number line, my other parts above. So I'm going to give myself some room above to draw. The next thing I'm going to do is color code my numbers. So I have a +5 and a +1. Well, that means in my number line, when I go to create my numbers, I know I need a lot of positives and I really don't need negatives, right? There's no negatives present in my number line. So what I'm going to do is I'm going to start 0 all the way over here. If I don't need negatives, then why put them in my number line? I don't need them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so I've done step 1 and 2. I've color-coded my numbers, and I've also created my number line. I'm going to take now my green and do my first integer, which is +5. Remember, starting at 0, which in this problem is right here, I'm going to go forward +5 because it's positive. Awesome, and I'm going to write +5. Now, starting from where I ended, which is again +5, I'm going to take green again. It's not red anymore, it's green still. And I'm going to create a new line and go forward 1. Now, where I end up in my second line is my answer. So what is 5 plus 1? Well, a lot of us already knew this, but now we modeled it. It's 6. So again, you don't always have to have green and red, right? This time it was double forward movements because it was 2 positive numbers. Awesome. Example B. -12 plus 15. All right. I'm going to draw in my number line again or bring my number line in. I'll put it down there. All right, and in my expression, I notice that I have -12 and +15. So I do have more positives than negatives, but it seems like I need -12 and +15. I need a pretty big number line where I need 0 to kind of be in the middle and big values on both sides. So I'm going to put 0 right in the middle, right here. What I also notice is I can't go by ones and get up to 15 and get down to -12. So I either have to create more values on my number line or I can go by different value amounts. So for instance, I'm not going to go by ones, I'm going to go by threes. So 0, 3, 6, 9, 12, 15. That means this is -3, -6, -9, -12, -15. Awesome. So now I'm going to take red. I'm going to start at 0, but my first integer is -12, which means I originally moved back. And I'm moving back to -12. That represents -12 or -12. Now, I'm going to start at -12 because remember that's where I ended. I'm going to take my green because now I'm moving forward 15. So not only do I have to move forward the -12 that I already traveled, then I have to move forward 3 more. And when I move forward 3 more, I get a total of +15. Well, what's my final answer then? My final answer is +3. +3. For the 12 you move back, you also move 12 forward positive and another 3 to get that +15. Remember, positives and negatives counteract. You can really see this on the number line, right? Okay, last example, example C. you have -1 plus -7. Again, I'm going to bring in my number line. Oops, excuse me. When I went to press my number line, I zoomed way out. Let me grab this, bring it down here. Awesome. So I have -1 and -7. So I have two negatives. What does that mean? I need more negatives on my number line. In fact, I don't need positives. I have no positive integers. So this case, I'm going to put 0 all the way over here. -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. All right, I'm going to take my red. I'm going to start at 0. I'm going to represent my first integer, which was simply back -1. All right, starting at -1, I'm going to take red again because I'm not going to go forward. I'm not going positive. I'm going back. And how much am I going back? I'm going back another 7. So 1, 2, 3, 4, 5, 6, 7. Where do I end up? I end up at -8. So as you can see with these number lines modeled, again, when they're both positive or negative, so both integers or values or addends are positive or negative, they combine for a bigger value in that same direction. So for instance, in example B, I went forward 5, then another 1. So they combined. There was no counteracting. There was no canceling. They combined to make a bigger positive value, which was +6. Similarly, in example C, I went back 1 and then I went back 7. So since they were both negative, they combined to make it's actually technically a smaller number because it's the farther away from 0, the smaller the number. However, it's -8 now. They combine because they go in the same direction, right? And they made, if you take the absolute value of -8, they made a bigger value, right? If you take its absolute value. The same cannot be true for opposite signs. So if both integers have opposite signs, or if the integers have opposite signs, one's positive and one's negative, the directions counteract each other. And therefore, we have some canceling involved. That's just like integer counters. When we had opposite signs, we canceled. Same signs, we never canceled anything. Well, on the number line, we can see if I have opposite signs, we go back then forward or forward then back. We have the canceling of values. All right. I recommend using this and integer counters to really solidify your knowledge before going to the algorithm that we're going to learn to help us add a little bit quicker. Thank you.